Welcome to Equivalence and Comparison of Fractions. So today's lesson rests upon the fundamental law of fractions, which is a rule that tells us how we can look at fractions that are equivalent. Given any integers a and b and c also, so that b and c aren't zero, the fraction a over b is equal to a times c over b times c. And it turns out that any two fractions that are truly the same value are going to compare somehow this way, that if I multiply the numerator and denominator by the same amount on one of the fractions, I'll get the other fraction that's equivalent to it. It's important that given an identity, you read it right to left and left to right. So if you read it from the right to the left, I see that if the numerator and denominator have a common factor, I can simplify the fraction by getting rid of that common factor, and I'll get something that is still equivalent to it. So why does this make sense, and how do we use it? So here's an example of the fundamental law of fractions, and I call it the fun law of fractions because it allows us to do a lot of things so much easier. You see two diagrams. They should be the same size, and the red portion is the same on both pictures, and so is the blue. And the blue portions are each 1/2. However, on the left side, I'm using it as one part out of two equal parts, 1/2. And on the right, the blue is 3 equal parts out of 6. So the blue represents 3/6. And as you can see, the blue parts are the same out of the same whole, so they are equivalent as areas. And continuing, if we look at the previous two diagrams, both have a red portion that's half the square. The blue portion is also half the square. But in the second square, notice that we have, and here I've talked about the red portions, 3 red pieces out of 6. I have doubled, tripled indeed, the number of pieces that are red, and the number of pieces in the whole has also tripled. And so instead of 1 out of 2, I have 3 times as many, 1 times 3 that are red, and 3 times as many, instead of 2 pieces, now 6 on the bottom, 2 times 3. So 1/2 is 1 times 3 over 2 times 3, or 3 out of 6. I could also look at equivalence by drawing it out on the number line, something that is very hot in math education circles right now. And so I could take a number line and I could mark out 0 and 1, and then divide that into 2 equal pieces. So below the number line, I have a 0, then a 1/2, halfway, and then a 1. And then maybe on the top, I would divide the interval from 0 to 1 into 6 equal pieces. So I'd have 0, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. And then you can see that 1/2 and 3/6 would be the same tick mark on that number line. So how do we use the fundamental law of fractions? If you read it from the right to the left, it helps us simplify fractions. And I've put in an example here, 15 over 21. 15 I have factored as 5 times 3. 21 I have factored as 7 times 3. And because those 3's are common factors, I can just eliminate those. And I see 15 over 21 is equal to 5 over 7. Now, what if we read it the other way, the usual way, left to right? Then we see how to create common denominators with other fractions, so we can do something like add or subtract, maybe even divide. And so I take 4/5 minus 2/3. I'm going to get the fundamental law to get denominators of, well, 5 and 3. Let's use a common multiple. Say 15 is the least common multiple. So I multiply the first fraction, top and bottom, by 3. That's allowed because of the fundamental law of fractions. Minus, now let's change 2/3 into a fraction with 15 in the denominator. I'd like to multiply the bottom by 5, so legally I can do that if I multiply the top by 5 as well. And so I now have, my first fraction is 4 times 3, 12. its bottom is 5 times 3, 15. So that's 12/15 minus, I have 2 times 5 is 10, divided by 3 times 5, which is 15. And 12/15, take away 10/15 is 2/15. Comparing fractions. So we know what to do when we have two fractions that we want to be equal, or I could even use the fundamental law of fractions to simplify both to see if they have the same value. But what if they aren't really equivalent? How do I tell which one is greater and which one is less? So I'd like you to think of how many different ways that you can figure out, given two fractions, which one is greater than the other. I've put some examples on the slide to help you think of ways you might do that. So pause the recording and do that yourself. Welcome back. So to compare fractions with the same denominators, we only need to check the numerators. So that's one trick if we happen to have fractions with the same denominators. I can use a handy reference number. So if I'm comparing 2/5 and 4/7, well, I know that 2/5 is less than a half, right? Because 2 1/2 would be half of 5. So 2 over 5 should be less than a half. 4/7 is more than a half because half of 7 would be 3.5. So 4/7 is going to be bigger than a half. I could compare two fractions that don't have the same denominators by getting a common denominator first. Or I could try converting both of them to decimals if I have that tool to do. You may have learned how to compare two fractions by doing cross multiplication. And that is a test that some people will tell you not to use at all because it doesn't really give you a lot of understanding. However, it isn't that hard to explain if you do enough examples for your students. So let's see how it works. If I have two fractions, one's a over b and one's c over d, I want to compare them. So the best way maybe would be to get a common denominator. So by the fundamental law of fractions, I'll multiply the first fraction top and bottom by d, and the second fraction top and bottom by b, so their common denominator is bd. I'll get AD over BD and BC over BD. Now that they have the same denominator, I only need to check the numerators to see which one is bigger. If AD is bigger, the first number is greater. If BC is bigger, the second fraction is greater. Notice that AD and BC are exactly those cross multiplication products, right? The numerator on the left times the denominator on the right. The denominator on the left times the numerator over the right. You could write those out and kind of circle the diagonals and see that you get what you may have seen before in elementary school. So we can cross multiply to decide which number is greater. And so really that test just comes down to the idea of I have found a common denominator. I'm checking the new numerators I get for this common denominator, and we're just being lazy in that we're not really writing out the denominators of the fractions when we make our comparison. So we're getting common denominators, the numerators are AD and BC. Do some more examples yourself to see how this works. I'll let you take a pause and do that. So now let's look at the caution part of this. Teaching this as a rule to memorize without any understanding is one more of those times where you are creating, or whoever's doing this, is creating one more example to a student of doing stuff that they don't understand, which can be really frustrating to everybody, right? So we don't want to turn math into a bunch of boring rules that you memorize. We want it to make sense, so they say, hey, this is something that I own, not something I'm doing because you tell me to. So you could either completely not teach this at all, or do this enough so that kids see why it works, so they can have this as a tool for themselves too.